Alright guys, so we're going to talk about Chapter 15, Air Pollution. This unit is very big in the AP exam, so make sure you look over this PowerPoint. So first off, the major components of the atmosphere are nitrogen, oxygen, argon, and carbon dioxide. Nitrogen being the main contributor at 78%. So the relationship between pressure and altitude, and how does it affect the amount of gas molecules? So troposphere is going to be the layer closest to the Earth's surface. This is where we're going to see most of Earth's mass and your weather occurring in your cycling of nutrients like your carbon cycle, nitrogen cycle, and so forth. Stratosphere is going to be the second layer. This is going to be much smaller in concentration, and it actually contains O3, which is ozone, which we've talked about a little bit whenever I did that diagram and I got distracted with my axolotl at the kitchen table with me. But if you notice, as you go up in the layers, the temperature will fluctuate. So the temperature is going to be rather cold in the troposphere, and then it starts warming up in the stratosphere. It gets colder in the mesosphere, and then the thermosphere, it gets super hot. So thermo, heat, kind of makes sense with that name. So in your booklet, if you want to go ahead and pause and write down the layers of the atmosphere just to kind of refresh your memory, that's a good idea. Air pollution is going to be where chemicals in the troposphere in high concentrations will harm organisms or ecosystems. And primary pollutants are going to be emitted directly into the air, while secondary pollutants is going to react in the air with something, some sort of basic component, and it creates harmful pollutants. Stationary sources, non-moving, fixed sites like chemical plants. Mobile sources, kind of like your highway vehicles. So make sure in your booklet, going back, in the stratosphere, remember in your booklet to write down what is significant about each layer, which we talked about with the temperature and the relationship between the amount of gas molecules, and what is the relationship between pressure and altitude. Make sure to write that answer down in your booklet. So in your booklet, we talked about primary pollutants and secondary pollutants, and the question is identify the gases as primary or secondary. So using this picture, pause the video, and in your booklet on page 17, write down whether it's primary or secondary for the different pollutants. And it shows you the primary here, secondary here. Remember, primary comes from a stationary source, while secondary reacts with a component in the atmosphere and creates harmful pollutants. Turning the page. Common criteria of pollutants. This is going to be regulated by the Clean Air Act. We have nitrogen dioxide, ozone, sulfur dioxide, carbon monoxide, lead, and particulates. So in your booklet, the 6 different criteria of pollutants, you're going to write down those components. Also, volatile organic chemicals is a big one in the AP exam. They love talking about it. This is where most of them are hydrocarbons and include methane, benzene, vinyl chloride, and formaldehyde. Carbon oxides, whether it's monoxide or dioxide. So monoxide is going to be colorless, odorless, highly toxic. Sources are going to be your auto exhaust, so don't be turning on your car in your garage because that creates carbon monoxide poisoning and you will die. So it does happen. Be careful. Don't do that. Burning of forests, fossil fuel power plants, and industry will also create carbon monoxide in the atmosphere. In your booklet, what are human health effects of carbon monoxide exposure? So human health effects are going to be basically you die and you get issues with your lungs. So it's not kind of, it's actually really bad. And carbon dioxide is going to be colorless and odorless again, but it's not directly harmful to humans. Most of the atmosphere result of natural carbon cycle. So we talked about carbon cycle way before in the first semester. It's been a little bit, so if you need to refresh your memory on carbon dioxide cycle or carbon cycle, make sure you look at that. It's also in high amounts is causing climate change, which is impacting our human health. So how we can reduce our carbon monoxide emissions. This is in the question on page 18. What air pollution control device did the EPA require to reduce carbon monoxide emissions? This is a catalytic converter. This is going to control our emissions from our vehicle. It reduces oxides such as nitrogen oxide, and it also lowers the carbon monoxide and the unburned hydrocarbons. So if you're really big into cars, I learned that it's very important to have a catalytic converter. My car decided to crap out on the catalytic converter and it was rather expensive. So make sure if you're driving a car, you kind of know what a catalytic converter and what it does just for your own personal information because, yeah, that was fun. Anyways, moving on. Nitrogen oxides and nitric acid. Nitrogen oxides are going to be colorless, odorless. They're going to be a form of nitrogen and oxygen reacting. If you need to refresh your memory on the nitrogen cycle, make sure to look at that from last semester as well. And also, a lot of the AP world calls it NOx, and that's just how people refer to nitrogen oxide as NOx. And then nitric acid, this is going to be HNO3. This is a reaction of nitrogen dioxide to the next level, and it combines with water and produces nitric acid. And it's a big component of our acid rain. That's a big thing for the AP exam. They love talking about how nitric acid causes acid rain. And at high levels, nitrogen oxides, they create issues with your eyes, nose, throat, lung, asthma, bronchitis. Very big, heavy stuff. So in your booklet, what human activity is responsible for the formation of NOx? That is going to be like our cars producing nitrogen in the air, and then coal plants. Nitrous oxide, this is another big pollutant. It's going to be naturally released from the soil and water as a part of microbial process of nitrification and denitrification. If you need to go back and look over those concepts. And humans are impacting it by adding nitrogen-based fertilizers, so at a high rate, it's creating issues. And climate change are the indirect ecosystem, and it's creating a huge human impact. Turning the page, sulfur dioxide and sulfuric acid. This is going to be colorless and an irritating odor. It's about 1/3 of the natural resources of sulfur cycle. If you need to go back, look it over. 2/3 from human sources like combustion of sulfur-containing coal, oil refining, and smelting of sulfur ores. There's actually like a sulfur mine outside of San Antonio. I always blame my husband farting at the same area at the same time. Then I realized once I looked it up, there's actually a sulfur mine. My bad to my husband, but it's okay. He farts a lot. Some solutions: low sulfur coal. So there's a lot of sulfur in our coal, so if we can make it low amounts, that would be great for the environment. Clean coal technology or coal washing, so you don't release coal in or sulfur into the atmosphere. And scrubbers is another one where they use water vapor and they trap the particles of sulfur dioxide passing through limestone, and it's converted into CaSO4 sludge. So coal mining will also use scrubbers. And this is what it looks like. If you want to pause and look it over, you can. Particulates is another air pollutant. This is going to be from dust, ash, fly, and liquid droplets. You get this with burning of fossil fuels in agriculture and construction. This is going to irritate your throat, damage your lungs, and can cause genetic mutations, so bad things happening. Electrostatic precipitators. This is going to be particulates. They're given a negative charge and attracted to a positive charge, and they fall into a collector. So again, if you want to pause and look at that diagram to get a better understanding, you can. Ozone. So ozone far away is good. Ozone close to the earth is bad. Ozone is going to be colorless and highly reactive, and it's going to be a major component in photochemical smog. So that's a big thing to know. Ozone, when it's close to the earth, is going to create photochemical smog. You have horrible breathing problems. You aggravate your lung and your heart, and you damage plants. Volatile, or hold on. So if ozone is a major component of photochemical smog, how can we reduce the amount of it? So we can reduce our emissions into the atmosphere. That will create less ozone in the atmosphere close to the earth. Volatile organic compounds. This is where organic compounds exist as gases and they evaporate and they become gas. Methane is going to be one of these. So remember, methane, landfills, cows, and these are going to create a lot of methane, so they create volatile organic compounds. Lead is a heavy metal, and it's mostly a problem from your gasoline and your plant paints that you paint on the walls, so they've gotten rid of a lot of lead paint. Ground level ozone. There's a question. Write the equation for ground level ozone. It's O3. And it's tropospheric photochemical smog formation. You have a combination of different things. You have nitrogen oxide or NOx through high temperature, and it combines with sunlight and creates hydrocarbons. So if you write that in a chemical or equation formula, do that in your booklet. Pause it and do that. Photochemical smog in Los Angeles, it's showing in 1968 it was a big issue, and now in 2005 it's getting better. And acid deposition. So rainfall has a pH of about 6, and acid deposition is going to be rain in the form of any other form of precipitation, and it's going to create an acidic form. Primary pollutants form secondary pollutants in acid deposition. So pause here and draw a pH scale to remind yourself. So you're going to have to look that up.